listening to Worth Electronics' What's Up radio podcast, where each week we are seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and our very own Worth Electronic technical specialists, and they're going to shine a light on interesting topics like energy harvesting, wireless power transfer, EMI issues, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Worth Electronics' What's Up podcast. Spring has finally arrived, but for many places, especially those in the north as well as the Midwest, it's still too cold to plant any type of garden. Without the help of temperature-controlled greenhouses, you really can't hope to start a garden from any type of seed. Even now, we're still expecting snow. Even with indoor greenhouses, the issue of proper lighting still arises. Well, now, with the help of agronomists, biologists, and engineers combined, sustainable food production with horticulture LEDs is a reality. Johan Walder is a business development manager with Worth Electronic. Today's podcast is based off a popular webinar where Johan introduces the newest products from our portfolio of horticulture LEDs and gives insights into the highly sought-after subject. He'll also demonstrate the most important features of the horticulture LEDs and answer questions such as what are horticulture LEDs and how do they support food production? What do you have to consider from electrical as well as biological views? And how does Worth Electronic support this technology as well as single applications? All these questions and more will be answered in today's What's Up podcast, Sustainable Food Production with Horticulture LEDs.
My name is Johan Walder. I'm Business Development Manager for Horticulture LEDs. And I prepared following agenda for today. First, I will give you an overview about the challenges of humanity. Then I will focus on new cultivation methods called controlled environmental agriculture, here especially on vertical farming. Then I will give you an overview about why we use horticulture LEDs in such a system. What are the benefits? What are the characteristics of horticulture LEDs? And in the end, I will explain you why you should choose Worth Electronic. What is our service? What are our benefits? And how we will support you in your application. Okay, then let's start with the challenges. I think everybody of you know that the world population is growing. So we expect, or it is expected that till 2050, around 9 to 10 billion people are living on our planet. Then we have also the climate change with extreme weather conditions. Then we also have a loss of farmland. And we also know that we have to save resources. So our resources are not endless. And of course, there's air and water pollution. So all this, a higher world population in combination with less usable farmland under unpredictable weather conditions is not a good combination and leads to the question, how can we secure the food supply in the future? How can we cultivate enough food for the growing world population? All these impacts and challenges need solutions. And one solution could be the horticulture LEDs. Horticulture LEDs can contribute to be a part of the solution. In the following slides, I will give you an overview how they can contribute to it. And therefore, I will explain you what is controlled environmental agriculture, the short form CEA. Controlled environmental agriculture is the cultivation of plants under optimal growing conditions. We have two main applications. It's indoor farming and it's the supplemental lighting in greenhouses. Vertical farming belongs to indoor farming, and I will focus today on especially vertical farming. I will give you an overview here, what is important in vertical farming, what are the benefits, and why are we doing this cultivation. So important for me is that you understand CA is a chance. It's not a competitor to traditional farming. It won't replace traditional farming, but it will support traditional farming. Yeah, a few aspects to vertical farming. What is it? Vertical farming is the farm of tomorrow. It is agriculture in the middle of the city and close to the customer. In a vertical farm, you can see on the picture on the left side below, we use a multi-layer cultivation system. So we cultivate the plants to the top. And so we use a minimum growing area. We also use their hydroponic systems. The benefit of a hydroponic system is that you have closed water and nutrient cycles, so you can save resources. And as I said before, we cultivate directly the plants in the city, so we have no long transportation of the food. We also can save CO2 here. And when we produce directly in the city, we can harvest on demand. This leads to a higher nutritional value of the foods too. So we can harvest the plants exactly when they're really ripe and not too early. Leads also to a better taste, for example. And it's 100% local. So in the end, such a system, in such a system, we can grow plants, grow food everywhere in the world. So it's everywhere possible to use such a system like a vertical farm and produce food, also in challenging places. And you have an optimization of the growth conditions. So this leads to to the same quality of the plant everywhere in the world. Yeah, here to summarize the solutions what vertical farming can offer you, and to summarize the solutions, how should I say? In the beginning, I showed you a few challenges in the world. Here, there's a few solutions for these challenges. Vertical farming, for example, with vertical farming, you can increase your harvest efficiency. So you have more yield, gram per square meter, because you cultivate to the top. You can cultivate year round. With this closed water cycles and nutrient cycles, you can save resources. You are weather independent, so you also can reduce the yield losses due to variable weather conditions. You cultivate in a multi-layer cultivation system, so you can compensate the loss of farmland. You produce directly in the city, so you also reduce the food mileage, so you save CO2. You also reduce food waste during storage or transportation. And of course, you also can reduce the soil degradation. So there's no uncontrolled leaching of nutrients in the soil. So you see, vertical farming has the potential to solve a lot of these challenges, or to be part of the solution to solve these challenges I told you in the beginning. Vertical farming can be used to improve food security and ensure nutrient-rich food while reducing carbon footprint and food miles. So on the next slide here, a short overview. What are influencing factors in a vertical farm? It's like in a greenhouse. Also in a vertical farm, the temperature, the leaf temperature, the watering, the nutrient content, CO2, humidity, or here also the hydroponic systems are a few very important influencing factors in a vertical farm. But the most influencing factor is the light. Without light, it is not possible to cultivate the plants. And we also can say vertical farming was made possible by LEDs. The reason, therefore, is the low heat generation of the LEDs made it possible to place the lumina, to place the LEDs very close to the plant. So the distance between plant and lights can be very, very small. And so that's also the reason why we can cultivate to the top in a multi-layer system. So on the next slides, I will focus more on the light. So what is important to know from biological side, from optical side, and from electronical side here. So I will start with the biological basics. So what does a plant need? Yeah, I already told it. So light is essential for plant growth. Here on this slide, on the left side, you can see in this picture, in this figure, different plant photoreceptors, different plant pigments. Which are the most important plant pigments, photoreceptors, and these photoreceptors are, you can say these are the eyes of the plant. So the plant will recognize the light with these plant photoreceptors, and you see here where the absorption is very high. So you can see here in the blue region, so from 400 to 500, it's very high, the absorption of the light. In the red region, and also here around 730 nanometers. To know, which is very important, the most influencing wavelengths in plant lighting are the 450 nanometer, the 660 nanometer, and the 730 nanometer. And of course, I said these are the most important ones. We also have photoreceptors here in the green region or in the yellow region. But here in this on this slide, I will show you the most important. So then you also see a border here between 400 to 700 nanometers. This region is called photosynthetic active radiation. Short form is PAR. So the region from 400 to 700 nanometer is the region where the plants are able to use for photosynthesis. Photosynthesis is the process which control nearly every plant developmental stages. So from 400 to 700 nanometer, the plant will use for photosynthesis, and we have the peak absorptions here at 450 and 660 nanometers. Then the second region we also mentioned here on the slide is plant biological active radiation. This is the region from 280 to 800 nanometer. This from 280 to 800 nanometer is the region where the plant can recognize light. Before I said 730 is also very important wavelength. So this is outside of the border here, but the plant also can recognize it. It's important, for example, for the flowering process. Or here, before 400, in the UVA region, this light, for example, can help to increase the secondary plant metabolites. Secondary plant metabolites are for us, for example, vitamins. So with different wavelengths, with different ratios between the wavelengths, you can control different quality parameters of the plant. We define quality parameters as, for example, more biomass, faster rooting, faster flowering or more flowers, better flavor. Yeah, exactly. There are many more. there are many more. You also have, for example, a better development of small plants could be also a quality parameter. But important here to understand, the plant have photoreceptors where they absorb the light wavelengths, the photons of the light. On the next slide, I will give you a few optical basics. So here again, we have the same picture as on the slide before with the absorption pigments of the plant. On the right side, you can see our LEDs where they emit the light, the photons. So you see, we also developed a deep blue LED with 450 nanometer, a hyper red LED with 660 nanometer, a far red LED with 730 nanometer. So these LEDs emit exactly these wavelengths which the plant can absorb and use for their development. So we developed our LEDs for customized light solutions for different quality parameters of the plants. And this is suitable for all horticulture lighting applications. And as I told you before, also here are photoreceptors and also UVA or in the far red region. So when you know what is your quality parameter, you can select the LEDs and can develop your own light recipe, or better, your own action spectrum for different quality parameters. Here on this slide, you get an overview about our high power products. So again, the three most important wavelengths, we call them horticulture LEDs with 450, 660, 730 nanometer. But again, we also have green wavelengths, UVA, also white LEDs in our portfolio. We will help you also to select the right LEDs, so to select the right wavelengths. This is something, what we offer you. We also have not only high power products, we also have mid power products. The same wavelengths again, 456 and 60, white LEDs, green, yellow, other red, other blue. It depends strongly on the application, which LEDs you will need in your application. And this is something where we can support you to select the right LED combination. You find also more information here on our webpage, shown here on the bottom with /letitgrow. There you will find all data sheets, much more information, but I will come soon back to this topic, what we will offer there. So that you also have a impression how the light will look like is a few pictures here on this slide. On the left side, you see basil grown under full color LEDs, so white LEDs. Here in the middle, you see a basil grown under monochromatic light. So here, especially deep blue and hyper red LEDs in a combination 2:1. You see this purple light and the white light. This is typical. Depends on the application, depends on your quality parameter, which LED and which LED combination you will choose. Here on the right picture, you can see how big or how strongly you can influence the plant development with light. This was an experiment with basil plants. So all environmental conditions like temperature, watering, nutrients, substrate, everything was similar. The only thing which was not similar was the light condition, the light quality. And there you can see, you can influence really a lot the plant development. Okay, so now you got an overview about optical and biological basics. I think you understand why we developed the special wavelengths. So now, on the next step, I will give you a few electrical basics. So what is important to know and how you can compare LEDs in this field. So we have three different parameters: the ppf, the ppfd, and the photon efficacy. These three are the most important values here for horticulture lighting. In horticulture lighting, you can, lumen or lux is not really important. So it's not, doesn't make sense to compare lumen or lux in horticulture lighting. So you always have to look on the ppf value and on the ppfd value, and at least on the photon efficacy. The ppf value is shown here on the left side. It's also called the photosynthetic photon flux. This is the amount of all photons emitted from a light source in all directions per second. So these are all photons which come really out of my LED. The unit is micromole per second. This is a very important value for luminaire manufacturers. For the gardener, the ppfd value is the most important. It's the photosynthetic photon flux density. It's the amount of photons that hit 1 square meter per second. So shown here. This is, you can say this is the amount of photons the plant really can use for their plant development. And the unit is micromole per square meter in a second. And at least we have the photon efficacy. The photon efficacy refers to how efficient a lighting system is at converting electrical energy into photons of power. So with the unit, micromole per joule. Also really important for the gardener. The more efficient my lighting system is, that cheaper is the lighting or the electricity costs for the gardener in the end. A few more characteristics for horticulture LEDs is that we can adjust the spectrum. So we can develop effective light receipts to obtain optimal plant growth, development, and quality. So we can select the right LEDs for different quality parameters again. And this is the reason why it is a lot more efficient than other light sources. And of course, you also can, you can drive the LEDs separately. So you can develop a dynamic lighting system. So for example, you control all the blue LEDs in one channel, then all hyper red LEDs in one channel, and all far red LEDs in one channel. And you can time them separately. So you can adapt your spectrum, your lumina, to different vegetation stages of the plants. So for example, a small plant, a seedling, needs other blue-red ratio than a bigger plant in the generative phase. Generative phase is, for example, the phase where the plant develops flowers or fruits. And here on the slide, you also can see a typical spectrum with the focused plant growth or more biomass on the left side here. And on the right side, you can see a typical light recept for with the focused flowering. So where you also have this far red peak inside. Okay, and to summarize now, benefits of horticulture LEDs in combination with vertical farming. There you have biological advantages, you have electrical benefits, and you have environmental benefits. So the biological benefits are you can cultivate year-round. You are weather independent, you have a high harvest efficiency, and you can increase your plant quality parameter. So in the end, you have more yield. LEDs, with LEDs, you also have electrical advantages. So a high lifetime of the LEDs, a high efficacy of the LEDs, lower maintenance costs, lower operating costs. This leads to less energy costs. So more yield plus less energy cost has the result fast return of invest, and in the end, more profit for the grower. And this in combination with the environmental benefits like resource gentle, space savings, harvest on demand is a good combination, and could be in the future a part of a solution to solve a lot of challenges. The green revolution already started. Vertical farming grows 24% every year. So you see the big potential which vertical farming has. It's important also to to consider that it is important where the vertical farm is, if it is rentable or not. So not in each place, in every places in the world, vertical farm is rentable at the moment. It also depends on how are the energy costs in this country, for how much you can sell your plants there, which plants do you cultivate, and so on. But you see, it's going on a lot in this market, and yeah, vertical farming has a big potential for the future. So then to my last point, what we are doing here at Wirt Electronic in this field, what service or which service can we offer you, and how do we support you, and why should you choose Wirt Electronic? Yeah, as I told in the beginning, so we deliver the whole necessary spectrum. So for all horticulture lighting application, we help you to find the right LEDs. So if you perhaps mid power, high power, full color, monocolor, doesn't matter what you need. We will help you to select the right ones for your unique application and target plant quality parameter. Our LEDs have a very high PPF output and also a really high PPE value. And I think you already know our existing excellent service like free samples, the availability of the products, and it's not necessary to order a minimum quantity of products. I think this one you already know. And additionally to these benefits, we also provide many more special horticulture application support. For example, we have own plant scientists in our team. We have cooperations with universities. We do research to find an optimum light recept or better an optimum action spectrum for different quality parameter of plants. Here on the slide, you also can see 3 different experiments. Again, on the left side, the basil under different light conditions. There we were able to increase the number of vegetation cycles of the gardener so that he can cultivate more plants per year. And yeah, in the middle, you can see an experiment with spinach. There we were able, with dynamic lighting, to double the amount of flavonols after 8 days. Flavonols are secondary plant metabolites. For example, for us, secondary plant metabolites are vitamins, for example. Also, the plant has a lot of benefits with more secondary plant metabolites, because secondary plant metabolites, for example, are helpful against bacteria or virus. And on the right side, you see an experiment which we did at the university with tomato plants. There we were able to induce the flowering in the winter months, and we managed it also to increase the flowers more than 40% than compared to other lighting sources. And all this knowledge we will share with our customers. So we will use this to share with our customers to select the right LEDs for their application. Yeah, we also have many more tools which you can use. For example, the spectrum design tool. It's also called the Horticulture. You can find it in our Red Expert. It's a tool where you can select the different LEDs I showed you before, and where you see immediately all relevant parameters. So PPF output, PP, forward voltage, how is the power, or which power, and you can select the different LEDs. You can do a lot of different combinations and find your spectrum for your luminaire. You see also, or you can change also the forward current there. You see how the different parameters will change when you drive them with 350 milliamps or when you drive them with 500 milliamps. You can see everything very, very fast. And you also see the different ratios between blue and red, green and blue, far red and red. So really helpful. We offer also a lighting development kit. In this lighting development kit, we include a power board with 4 channels, so you can drive different LEDs separately. So, for example, you can drive the deep blue and the hyper red separately, so you can time them also separately and develop your own light receipts. In this lighting kit is also a LED panel included, or more LED panels included, with hyper red, far red, deep blue LEDs, white LEDs, and also other colors. You have also optics inside, a cooling body, so everything you need for your first own luminaire. And you can control all the LEDs there with our VE illumination app. This is also an app which is for free. You also can find a lot of more information on our webpage. You see again the webpage here below in blue. There you can find more detailed information about vertical farming, horticulture lighting, what is important, and a few more basics here. Okay, outlook in the future. What will be important in the future here? Artificial intelligence. This is a lot of new projects are dealing with artificial intelligence and controlled environmental agriculture. Also, autonomous greenhouses. They are also a form of controlled environmental agriculture and will be also very important in the future. To this topic, autonomous greenhouses, I also will give a webinar next week. Also on Tuesday. If you have time, I would be happy if you will join this too. And also the cultivation of crops everywhere in the world or in the space is a big topic at the moment. And the integration of vertical farms in the circular economy is also a big topic. To summarize, we are faced with more and more challenges. As I told you in the beginning, climate change, growing world population, loss of farmland, the need for a better use of resources. And we need to solve these challenges. Wirt Electronic is actively accelerating the green revolution here by supporting development of the farm of tomorrow to ensure sustainable food production.
This podcast was taken from an updated Worth Electronic webinar. To view the materials and replay the webinar on demand, visit our website at www.we-online.com/webinars or click the link attached in this podcast. You can learn more about horticulture LEDs and find our complete LED portfolio by visiting Worth Electronic online. You're listening to Worth Electronics What's Up Radio podcast, and each week we are seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and Worth Electronic technical specialists who are going to shine a light on interesting topics, such as energy harvesting, wireless power transfer, EMI issues, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Worth Electronics What's Up podcast.